Hello and welcome to the Module 3, third part, Security. Here we will talk about security aspects of the IoT. Internet of Things is a concept that must be always treated in a context of security. Security defined as the protection of information system from theft or damage to the hardware or software and to the information on them, as well from disruption or misdirection of the services they provide. Encryption helps to attain this objective. SSL provides a secure channel over an insecure network in a client-server architecture. SSL uses public key cryptography to authenticate the remote computer. Public key cryptography uses two different keys, one for encryption and the other for decryption. The encryption key is usually made public so anybody can encrypt a message with that key. Because the decryption key is kept private, only their holder will be able to decrypt their message. This has the advantage of simplifying the key exchange mechanism. However, the full security of the chain relies on a certification authority that certifies that the public keys are authentic. SSL is a very complex protocol where public and private keys can be generated and exchanged, or using existing keys can be used. Also, the protocol starts a negotiation between the client and the servers to agree on which exact encryption mechanism will be used. SSH can use a lot of encryption algorithms and standards, but a client or a server may not support all of them. The negotiation phase tries to find the most secure and commonly available method. As you might detect already, SSL is not a lightweight protocol. And its encryption method sometimes must rely on dedicated hardware. For this reason, we must remember that when using small devices running on low-end hardware, we will have to find another methods to provide a secure channel for our communications. However, keep in mind that this task won't be always possible. From the user perspective, we use SSL in three important situations: to remote access a computer, for tunneling, and to create the protocol HTTPS. SSH is a command that allows accessing other machine through a secure channel. SSH can be used as a command line application on Linux-based systems. On Windows, we can use PUTTI, which is an SSH client. To transfer files from the host machine we can use also the SFTP and the STP commands. Most FTP clients, such as FileZilla, allows using SFTP as protocol. STP is the intermatching equivalent to the CP command line command. One of the most interesting capabilities of the SSH protocol is creating encrypted connections or tunnels that allow accessing a remote service as if it were present in the same network. This allows secure connection through firewalls and NAT services. Using the command line, we can create a tunnel with the following command. The F tells SSH to go into background just before it executes the command. This is followed by the user and name and server you are logging into. The L2000 personalservers.com 25, which has the form of local port, host, remote port. This assigns which ports are going to be used, and the client server are on the remote server. So we are connecting here the 2000 port to the 25 remote port. So when we are accessing on the local host to the 2000, we will all the packages will be redirected to the port 25 on the target system. If I point my email client to use localhost port 2000 as the SMTP server, then it will send the email through the channel straight to port 25 on personalserver.com. HTTPS is a HTTP protocol wrapped in a secure channel. All communication on HTTP are made on plain text. HTTPS is nowadays recommended as the preferred protocol. HTTPS is based on certificates emitted by a certification authority. To promote the adoption of HTTPS and the HTTP deprecation, a new free certification authority called Let's Encrypt has been created. Let's Encrypt is a certification authority that is completely automated. All the processes are open and is free to the public. Let's Encrypt is run by the Internet Security Research Group, who is a public benefit organization promoted by private companies like Cisco, Mozilla, and universities like Stanford or Michigan. Despite the usefulness of SSL-based protocols, we have seen a new concept of web services based on Open API that provides services to other applications. In this context, the authentication of users by these APIs is a complex task. OAuth 2 is a very common protocol to solve this problem. In OAuth protocol, first an application shows a login button. Then the user clicks on this button, which redirects the user to the OAuth authorized page on the OAuth server. This page showed in the OAuth server is where the user provides the password, not in the application. When the users accept to access their private data, then the OAuth 2 server redirects the user back to the application's callback URL with a verification code. This verification code is used to request an access token that will be used to make further requests to our restricted resource. Now we are going to see a demo of the OAuth 2 protocol. First, we are going to install the library OAuth 2 for Python using the pip install command. You can find more information about this library on the GitHub link that is shown on the screen. And in our example, we are going to use Twitter as OAuth 2 server. So Twitter is going to allow our access or not, depending on if the user accepts it or not. And the code is quite complex because the protocol requires several steps, but it's not so difficult to understand once you follow the logic of the steps. So we are going to use the consumer key and the consumer secret that Twitter gave us when we register as developers on the portal, and then we can configure the token access URL and the request and authorize, which are the links that we need to use Twitter as authorization server. And because we are going to do it on Python, we are not going to rely on the redirections mechanism, so we will need the user to go to a web page and click on authorize. So let's open our example. We first open our code, and we see in our code our consumer secret and our consumer key, and also the request tool for the tokens and authorize. When we run the model, it provides us with the URL where we have to go to authorize the application. So we copy the URL, we open an internet browser, we copy the URL on our internet browser, and it will give access to our Twitter OAuth server. So we will authorize there. We will log in on our account. and we will authorize the app. Web apps, we will redirect to our app, but in this case, they provide us with a number. We will insert in our script. So we will continue with the authorization process. So we ask yes. We provide here the PIN that we have copied, and they gave us our tokens, and those tokens we will give access to protected resources. In this lesson, we have seen how to access our Raspberry Pi using SSH. We have secured our services using tunneling and explained the importance of HTTPS. We also have seen how OAuth 2 works. In the next lesson, we will describe the different options to connect wireless to the network.